Hey y'all, I am Ash Growem, and this is FusionPunks Podcast, episode number 3. So, welcome y'all. Today we've got Dorian Demetrulias back with us, and we also have a new guest, Wes Savage. If you guys want to introduce yourselves, give a quick background and what drew you to Geet, Thunderstorm, free energy in general. Yeah,
Shall I go first?
sure thing.
All right. So, yeah, my dad is a construction project manager. He's been very interested in like Earthship style architecture since the 70s. And that's kind of been like a family value, this interest in renewable energy and is it leadership and energy efficiency design is something that my dad's been interested in. And so kind of following in his footprints as far as helping the advancement and deployment of new energy technologies. And now that I'm working in data center operations, looking to advocate for the plasma reactor technology to be implemented in that regard. And I guess it first basically began with going down the rabbit hole of the Geet reactor and then building it and now replicating thunderstorm generator and comparing the phenomenon and now conceptualizing my own design for a similar type of device that uh, utilizes that same low energy nuclear reaction phenomenon. Um, yeah, very grateful to Paul Pantone to have been one of his final apprentices. Special honor. So I'm just looking to continue the advancement of the concepts that he put forward and to encourage other people to experiment with it as well, such as we're doing.
Awesome. Thanks for joining us again, brother. Wes, do you want to introduce yourself?
Thank you. My name's Wessley Kane Savage. They nicknamed me the Shrimp Po Boy, kind of a moniker of my background culture and being kind of similar in some ways to the comedian Ron White. I started in the quote unquote fringe tech stuff back in, I guess, around 2010 when I started learning into Nikola Tesla because I realized he had certain posthumously diagnosed neurodivergent slash autistic spectrum quirks. I have the same ones that he did, but mine were less severe and were harder to remember. I'm glad because I don't have to wake up with migraines. That drew me to research into him further. Then from 2012 to 2013, I found Thomas Henry Moray, and that I recently finished that 16 so 16 years later, as of the present, I finished that research on myself, and I've open sourced and I've convinced other people to open source documents that are crucial to the understanding of it that no one else has done. So you're welcome. I only did it in the name of the work and vindicating Moray instead of having him naysayed. Then around the same time, I had discovered Jean-Pierre Marie Chambrin's water ethanol fuel reactor, and which interestingly paralleled the hexameter design. And his last global patent had already been filed at the same time that Pantone independently finished his first Geet reactor, the blue Briggs and Stratton engine powered with the unique looking bubble and everything. And then I went further down that rabbit hole, both rabbit holes at the same time. I don't know how the hell I pulled that off, but I did. So that led me to learning about the absolute crimes against humanity and white collar crimes done by the state and the deep state to Paul, which is why I did the video series, the Geet is Not a Fraud, the Paul Pantone Expose series, which is a really old video series on my channel. And around 2012, 2013, I got to know David. I love him like a brother. Still think highly of him. We got pretty close. And and I continued the research on my own in the name of Paul, because I wasn't his apprentice, but I was in contact with him, and I did occasionally talk to him, and I'm gotten to learn from my dad's mistakes of many a mistake in judgment of character. So I could say I could be an okay judge of character. I'm quicker to sniff others out because I'm a sniffer. Yeah, self-centered. It's quite convenient. So I can sniff before others and catch on before others. I don't know how, but I got the knack for that. So yeah, he was. I could tell he was genuine, and and so I continued when I was building my first gate reactor, which I finished. I just need to get my tiller running so I can install it on there and get my other two finished so I can put them on a whole house generator and another piece of equipment after that, because that's my intention down the road. I said that in my last video series on the Geek Tech and how it works, which, by the way, folks, you can thank Dorian Demetrulias for reaching out to me and commenting in my comment section of that particular video series, or else I wouldn't be here.
That's right.
And Ash wouldn't have convinced me to make my own Substack. So,
Yeah, and also West Savage, your YouTube channel is Derpy Redneck, and that's also, it's funny because I had actually found you when I was searching when I first discovered Geek. You were one of the few people, along with Dorian, that I found that had some semi-recent videos, and we're talking about and discussing it. So that's cool. Also, the hexameter is the name of Dorian's personal take on the Geek, 6 chambers. But
That's basically why I wanted to bring Wes on, is because of his knowledge about the Chambered Reformer, which I wasn't even aware of. Like when I began the design for the hexameter, it just occurred to me that we should make it in a way that has symmetry, a rotational symmetry that's going to evenly distribute the heat energy from the exhaust into these heat exchange chambers. And that just happens to coincidentally be a very similar type of design that Gene Cameron came up with, which it's almost like I was tuning into some ideas in the field of possibility that Cameron had already conceptualized.
Yeah.
That's
why I brought it to your attention when I did. That's why I had that. Another thing I was always quite good at as a kid, not to brag on myself, I'm not trying to, I'm a hell of a good deducer. That's why Sherlock Holmes, The Shadow, and Batman were very big favorites of mine when I was little.
I break down the similarities between my design and Cameron's.
Well, the Chambered reactor has 6 chambers in exact same fashion that Dorian's had. Well, not exactly. He's just all the way around. It's 5 outer chambers in a circular fashion, and in the middle 6th one, there's no reactor rod like a Geek like Dorian's did, although that would be a benefit to the Chambered design, I would argue, for multiple reasons I won't go into right now. Or maybe we could do it in the future if we don't have the time here. Another thing is it uses exhaust. It has an exhaust come up on one side of the chamber, of the outer chamber, and then spiraling around the 6 reactors inside the reactor intake pipes inside the main reactor chamber, and then it comes out the opposite end. And then if you built it, if you desire to build it this way, the final exhaust extraction could come and vortex outward parallel to an intake channel, right? Spiraling exact same way, but inward, the exact copying of the fluid motions of tornadoes, hurricanes, fire twisters, and funnel clouds and the like, after being fed by a carburetor.
So this is another element of the Chambered reformer that I thought was interesting, is that there's a part of it that it looks like an S-shaped spiral, or it's almost like, when I was a kid, I used to draw mazes for fun. And part of one of the mazes I drew, I made there was a spiral, but if you went all the way into the spiral, there was a path to come back out of the spiral. And the Chambered reformer has that design to it.
Yeah, that's the final stage of the exhaust and the first stage of the vaporization feeding into those 6 chambers for the reactor.
So that's a heat exchanger basically by having it like
Yes.
walled like that. Yeah.
See, I had a theorizing that I'm gonna tell it because I had this for more than a decade as an idea. I had the idea of a Zeta Pinch driver circuit that had a certain couple of unique features at it. I've given Dorian and Ash a couple of great details.
So what
that
is
would
the Zeta
inject
Pinch?
a Zeta Pinch. Okay, you know how you got a plasma that's flowing this way. The pinch happens along in a vertical way that clenches right down at that spot.
Along the
So if you
reaction
got
rod?
yes, it's a Zeta Pinch. In fact, I brought this to David's attention and certain other geek including former geek dealers all I encountered on Discord. And I said, wait a minute, this is nuclear physics stuff because there's a company just trying to make a Z pinch plasma pinch derived nuclear fusion reactor that's they hope to become break even hot fusion, like hot plasma. And I'm like, wait a minute. So I put 3 and 3 together, not 2 and 2. I put 3 and 3 together. And then I'm like, okay. So the friction of the various molecules of various viscosities vaporizing, rubbing against each other, spiraling as it go into the gate, can do the sheared flow. Now it's flowing axial along the rod, between the rod and the inside wall of the intake pipe. That's an axial sheared flow. That can actually stabilize and keep a Zeta pinch, which is the main type of plasma pinch, existing and going. They use this technique to make better, more efficient Z pinch driving reactors.
So in the Z pinch that's like the epicenter of a magnetic field that occurs from the hot and cold gases flowing in opposite directions that creates the Seebeck effect. And the Seebeck effect, the static electricity arcing around that bullet makes this magnetic field that makes the bullet kind of levitate. And there's a field, a magnetic field that when the vapors pass through it, they are becoming concentrated or
You're right. But so when you start the reactor and you pull in a vacuum on the vapors, the exhaust going down. Excuse me. So the vapors coming along up the intake pipe and around the rod, the vacuum goes up, increases, because that narrow venturi around the rod, the surface of the rod, that serves as another venturi because of Bernoulli's principle or Bernoulli's law. If you raise the vacuum or lower the pressure of a fluid, it speeds up. If you raise the speed of a fluid, the vacuum goes up or pressure goes down. Sorry, excuse me. What happens, that hot and cold flow plus all that vacuum effect is what makes the rod able to hover and spin. It's like if you flung a car, like same way a hurricane picks a car up with high winds and flings it. Well, you're using that to feedback loop and intensify that effect and magnifying that vacuum. And that's what keeps the rod hovering and spinning using those natural forces. But then you have when you build the triboelectric charge, electrostatic charge in the vapors, and you have remnant magnetism in the bullet rod, the intake pipe, and the exhaust pipe matched based on opposites attract, and you follow the electrostatic rules of thumb, opposing electrostatic charges rubbing each other induces static
remnant magnetism. You're talking about the charge that starts to build up in the bullet because it has an iron core after it's been run in the reaction chamber.
No, I mean the actual remnant magnetism that you can detect on a lot of iron and steel rods and pipes that you can detect with a composites remnant in the material. that can
but that monopole effect that builds up after the rod's been run in the reaction chamber, that in
that's
itself, that has some energy to it that it's probably imparting to the gases that are moving past it.
yes, but yeah, the remnant magnetism is amplified. So the remnant magnetism, you want it to match up like that so you can to ensure an electromotive force and electromagnetic path that's proper and is properly able to establish. So Faraday's law is invoked on the bullet rod as it spins, and the sparking happens all around it. Because if you go back to the research materials of Charles Steinmetz, Michael Faraday, Oliver Heaviside, Charles Fortescue, and Eric Dollard, Dr. Andre Assis, and I'm trying to remember a couple of those, like Master Ivo, I think, the YouTuber. The guy who recently did, trying to remember the YouTube channel's name, that did the Forgotten Law, the Amper's Law, who cited the works of Andre Assis in the citations of his videos. You have electrostatic and magnetic lines of force that when they collide together and charges move. That together induces electricity. So you have that remnant magnetism lined up, and static electric charge, electrostatic breakdown sparking, that lines up to induce electric current. That electric current sparks around that spinning ferromagnetic permeable bullet rod. That's why Paul emphasized this. And
So is the Leonard happening in the zeta pinch?
Potentially, yes. Potentially, if the conditions are favored, yes. But it can also happen in the combustion chamber if the mostly oxyhydroplasma if it's excited and ionized hard enough, it'll collapse on itself when the piston comes up to squeeze it, and it'll implode inward, pulling the intake air into it, making a homogeneous mix. Now, what's funny? Yeah. I think I'm the only guy that actually brought this up. This is a missing key for like Leonard and plasma, like plasma fusion, and for like detectable helium in the exhaust of the geek. Sorry, had a decent supper, folks. Sorry that I've been muting myself for that. So basically, there's deuterium all in the environment. All water has heavy water in it.
Right.
So when you ionize and you
experiments.
Yeah. So that gets those deuterium, those deuterons, as they're called when they're ionized, get liberated. That can be forced together by collision or by just quantum tunneling in that Z pinch along the bullet, or it can happen when that oxyhydroplasma or geek gas and those deuterons and occasional tritium ion that's rarely in there will come together and tunnel into each other when that syngas plasma implodes on itself and it goes to the center of the chamber, and that forms that negative potential well that the tokamaks and the Robert Bussard's polywell and the Farnsworth fuser and the POPs modification of the Farnsworth fuser and all those are trying to maintain it, and that's also that the what little Leonard could happen in that density point with all that negative potential well, that can generate the self-ignition excess heat,
without a spark,
to generate the self-ignition. Exactly, without the spark, and that's how that can happen.
So the Leonard low energy nuclear reactions are, I believe it's beginning in the zeta pinch in the reaction chamber, where first it's dissociating it's breaking down hydrocarbons or water vapor into hydrogen molecules, but then it's actually taking apart the hydrogen molecule. It's basically fissioning apart the atom in the zeta pinch or in the cavitation zone at the top of the bullet, which they say creates a white hole, the other end of a black hole. And that decomposed hydrogen proton or whatever plasma soup is going into the combustion chamber, and then the fusion part of the Leonard happens in the combustion chamber under the compression stroke when the implosion happens, and then the what would have been carbon atoms become converted into oxygen. That's like stepwise fusion happening.
Yeah. So exactly. So the yeah, exactly. The molecular hydrogen is fission and was split up chemically into hydrogen, and it's further ionized into protons, like you just said. Yeah, that's how it goes. That's what happens. So
and I'll just interject quickly just to give the audience context that may not have the engineering background. We're talking about the inside of a GEAT reaction. GEAT stands for Global Energy Technology, something similar to that. What was it?
Yeah, global environmental energy technology. You just missed the first word.
So this is basically, it's a modification. I mean, you guys can explain it better than I, but just to give the audience context of what we're talking about, this reaction.
To simplify, folks, you have basically a bullet-shaped rod that has at least a dozen functions in itself, an intake pipe, and an exhaust pipe to go around it. You make what's called a counterflow, opposing flow heat exchange, and if you condition it right in the vapor-making section right, it can induce its own plasma. And
similar to a Rankine vortex too.
Exactly, but it can generate its own plasma if you monkey with it just right and get the conditions right. And that can make a super clean plasma reformate or syngas in the gasifier industries. But it's
That's
a plasma. It's super excited. And it burns ultra lean, extraordinarily ultra lean, and it also burns cleaner. And it can bottom out pollution to zero. And in some cases, they've actually put out more oxygen. In some cases,
with the thunderstorm generator, which is a very similar type of engine modification device, which also involves a thermoelectric heat exchange process that's adapted to the exhaust system. And with the experiments I've been doing where I put the generic Mountain Dew soda pop in the water bubbling chamber, I've seen it go up to 25 or 30% oxygen in the exhaust in one experiment I did. I did one, the first time I did that experiment, I saw it go up to 22%. And I told my friend about it, who also is interested in hydrogen research. He said, "Oh, that's just a fluke." But now I've replicated the experiment and I've seen it go even higher above atmospheric levels of oxygen, which again is very curious to see it go above atmospheric levels of oxygen, because people that are skeptical of my experiment say, "Oh, you're letting ambient air contaminate the sample, and that's why you're seeing high levels of oxygen." But if we're exceeding ambient, then where would that be coming from? And it can imply that it must be there's some kind of special type of atomic reaction, low energy nuclear reaction.
Yeah, there is. Yeah, it is. It's fission and transmutation across the board. Yeah, but
and the sun does that all day, every day, and it's using a plasma field, and that's what the zeta pinch is. We're simulating a plasma field like the sun, and we're able to create the conditions that allow taking apart atoms and then rebuilding them in the combustion chamber.
So now, folks, if you don't get the implications, Paul Pinton since 1983 and Jean-Pierre Marie-Chambrin since 74 and 75 in France before that, and Malcolm Bindall since he started pushing the thunderstorm generator, these guys are doing what particle physics openly admit it's really hard, okay? It's for conventional means, it's really hard to make fusion happen in a plasma and keep it going. It's even harder to do fission and other new transmutation events. But these guys seemingly have done it, and they're in the geek community that used to be on Yahoo groups, which I was one of the very last members of. It's how I got a lot of the info before it got shut down by Bill Gates' cronies. I'm trying to be PC here. I could say a lot worse. Oh, they know. They've heard me on the phone, folks. Trust me. If any of you seen my channel and seen some of my content that got deleted by the Jannies and their algorithms, you'll know. I could say plenty worse. I might make Satan embarrassed. So,
Yeah, I'll
yeah.
pop in here too. So the thunderstorm and the geet are basically, these are modifications to modern day gas combustion engines that basically convert what are, unburnt exhaust gases. It converts it into oxygen. And it does increase the efficiency if you build a geet reactor. And so basically, any off-grid generator, a lawnmower, like your tiller, even industrial-sized turbines and generators, steam generators, these can all be modified with a geet or a thunderstorm, and you would basically, depending on how well you build it, you can increase the efficiency. I think I've heard from anywhere from 25 to 100% efficiency. And also there's been rumors here and there that so you're converting the exhaust gases, carbon monoxide, CO2 to oxygen. Basically, all of the noxious, toxic gases get converted to oxygen, about ambient in the atmosphere, like 22% or better. And I mean, just that alone, like, like big billionaire money could take that and say, well, here's the new green. Like, basically, if you modified your car with this, you could basically claim that you're greening the environment. Not only are you greening the environment, you're saving money at the gas pump. So that's
You actually
the
get paid a
implication
carbon
there.
credit.
Yep.
Right.
And
right.
this is a green technology. This converts the entire gas, coal, and oil industries to regenerative technologies. This means we don't have to rebuild. We don't all need to buy electric vehicles, and we don't need to create an entirely new,
Infrastructure.
we
We can use our existing infrastructure.
Exactly. We can take what we already have and simply, and I'm not thinking of the word, but we can take what we already have and just add some modifications. And now all of a sudden, so this is kind of the transition between here and, anti-gravity and fusion, is this kind of low energy nuclear reactions and hydrogen. So here's the other implication, because there's been rumors, at least that I've heard, and you guys can help me figure this out, but that some of these geet reactors or thunderstorm generators can use water mixtures in them, and so they
and
can
that's how
also
we get to
break down
over
the
100%
water.
efficiency.
That's how you can get over 100%
Now,
fuel economy increase. Some people have used 20%, 18 to 20% petroleum, and the geek guys and Paul and certain other people have done this, would use Angola crude, because you don't have to thin it to any degree with a hydrocarbon solvent to get it to be pourable, because it's one of the few petroleum deposit areas on the earth that actually has a pourable petroleum, as it's pourable coming out the ground. So they prefer to use it. That's why Paul emphasized using it, because you didn't have to adjust and all that, and then burn a new rod in by running a new rod for anywhere from 35 minutes to 2 hours. Take it out. Start taking a liquid compass like this one. Okay, pretend that this phone I took one of the batteries out of to keep it shut up, so it wouldn't interrupt us. Pretend this is a rod, one that hasn't been, that's just come out of the reactor. You move upwards, and then the north hand of the compass will spin and point at the spot you want to mark red with red chalk, and go there and move down enough for the south end of the rod of the compass, south hand, to spin around, point at that spot, mark that with white chalk or ivory. Get a caliper, measure that, and get the millimeters in length. Write that down and what mixture you used. Get a new rod, cut that sucker in, give a little excess length so you can file it and smooth it down to a bullet shape on the magnetic south end, which you need to detect with the compass. One end points north, keep it flat or cup it with the south end of the new rod. The remnant magnetism that points south on the liquid compass, like this one I use. I got two of these. you file down to a bullet shape. That's why Dorian calls it the bullet rod. I do too sometimes. I'm just used to calling it the geat reactor rod or reactor rod. So, and then you just burn it in for at least 35 minutes to 2 hours, and it'll run on that mixture. To tune the geat, you just do the same process over again.
So I see what you're saying now about the remnant magnetism, because I looked it up, and that's basically, it's the induced. It's when something is, I guess, ferromagnetic. It's not. It doesn't already have a permanent magnetic field, but then it's induced through electromagnetic fields, and then there's a leftover permanent field.
There's a small, exactly.
It changes depending on the fuels you put into the. What you're saying is it changes depending on the fuels you put into the geat reactor, and so that's where the conditioning happens.
Yeah, because it interacts with the atomic mass of the fuel mixture.
And the remnant magnetism is a permanent. It's a very small permanent magnetic excitation on the ferromagnetic material. You want the intake pipe, the exhaust pipe, and the reactor rods to be matched based on again opposites attract. You want the south end of the exhaust pipe and the reactor rod pointing one way, and the intake pipe south end pointing the opposite way.
Does that happen automatically?
No. When you get like duplex stainless steel, ferritic stainless steel, regular steel, iron or magnetite plated, also known as black iron pipes, when they're made, they might have a certain remnant permanent magnetism. It's a small amount, but it's enough to pick up on a compass. That aligns in conditions and enables a proper path for Faraday's law induction and then Lenz's law to happen on the two pipes to happen. It leaves you a good path so you don't need to already built up and set up for it.
Okay, but you're saying with the right materials, so once you've built your modified geat reactor engine, running it with whatever fuel you have, hopefully if you've used ferromagnetic metals, it will condition itself properly.
Yes, that's why you want to match up the remnant magnetism on those materials using a compass based on opposites attract. You make that electromotive force and electromagnetic path for self-conditioning to be ensured. That's what you want. And you want the vapor making side to facilitate triboelectric charging, so you can build static electricity. So you get a charge and the vapors ready to start sparking in there.
Yeah.
And that'll ensure the beginning of all these processes.
Yeah, and I'll throw in even a little more context. So basically, we're deep into the weeds here because you guys are experts. So just to give anyone who isn't following us, is we're talking about the inside of this geat reaction, and on the inside of the geat reactor is basically a pipe that you put, if I understand, before this pipe goes in to the combustion chamber to where the piston is, right?
No, no.
Running the fuel line inside the exhaust pipe.
Well, you're running a fuel line into a metallic intake pipe. That metallic intake pipe has the bullet rod inside of it, and then you have the exhaust coming to go wrap around the middle of that intake pipe that has the rod in it. The output of that intake is what feeds the combustion chamber.
Okay, so basically the geat reaction, but the geat reaction is feeding the combustion chamber.
Yes, directly.
And it's receiving
reformant gases are fed into the intake.
And it's receiving the exhaust.
Yes, through the fat
so
pipe.
it's a closed loop. There's no more exhausted pipe anymore.
Oh, technically,
it can be.
Yeah, you can be. The way you have to ensure if you can establish a closed loop is if you have all these reaction conditions right. Dorian's
then
laid
you can shut the valve and recirculate.
You can shut. Yeah, you can recirculate the exhaust. The ideal way Paul talked about doing is half of it could be routed to a bubbler or split into or sent to intakes of like modified carburetors to mix with ambient air.
Mm-hmm. And
then the other half could be directly routed to the intake of the engine. That's the best way to do it because you
Oh,
minimize
why?
noise.
Oh, yeah?
I think two main reasons is to minimize back pressure. Because, the
Oh, yeah.
exhaust still coming off is going to have a bit of a, just going to have a little bit of it's expanded, but it still has a little
Depending
bit of an
on
above
what
atmospheric.
temperature it's coming out and how efficient your reaction is. And that's the point of the hexameter reactor design, is to potentially
Yeah.
soak up more thermal energy. And we should actually get the exhaust coming out colder than ambient air temperature.
Well, let's talk about that. The ice on the pipe thing.
Yeah,
Yeah.
but even if it's cold, when the piston pushes out exhaust, regardless of temperature, it's going to be a little bit above atmospheric pressure, regardless. But you can minimize that with what you were saying, Dorian,
The
by
shock wave
extracting
part of it,
more.
like Malcolm Bendel talks about shock wave.
Yeah, it's similar to one like that. Yeah, it's a pressure wave. It's a pressure wave, but you can lessen the pressure wave by extracting the heat kinetic energy.
Like acoustic energy instead of thermal energy.
Right. Yeah. There you go.
Well, that reminds me of that what I'm talking about, the thermoacoustic engines or whatever, like the Stirling, or no, there's another one that's there's like you light a fire in a tube and it's actually this acoustic wave resin. Oh, it might.
That sounds like a Stirling engine. That's a heat engine.
But there's another one.
Do
you know what I'm talking about? Standing wave. Anyways, there's a lot of cool things. That's another effect you could utilize. I've seen this. If you go on YouTube, type in like thermoacoustic. There is a way to take thermoacoustic engine. Let me see the actual name. Thermoacoustic Stirling engine. There's another name, but I'm sure someone in the comments will figure it out if I can't figure it out here. But anyways, so yeah, there is a way to like get some. There's the Stirling engine, but then there's also like a standing wave thing you can do with the flame. But yeah, so I wanted to ask about so basically it's a closed loop other than the carburetor or the choke or whatever. So you're just closing the loop more, but it's still breathing occasionally.
Right.
Okay. And we're just taking the exhaust and reusing it. It's very permaculture.
Yeah, I think as long as the exhaust is over like 16% oxygen, that should be enough for it to sustain combustion.
Okay.
Right.
So I've heard rumor that some of Paul Pantone's exhaust pipes were like there was ice crystals forming on them or whatever. So if you can explain that, and is that just because, how is that happening, right? Because is that because of a highly efficient? Is that because so much heat is being sucked up, or is there some?
Yes.
Because I've also heard, I think it's with the Searle effect generator or some of these vacuum devices that as they hit a certain resonance, even the Hatem magnetic motor, that they get cold, and that's because they're sucking energy from the environment or from the vacuum. And anyways, all right, clear me up here.
Yes, go ahead, Dorian.
So basically the idea is that the Seebeck effect is when we're turning heat into static electricity. And if you have your reaction rods tuned correctly per the fuel mixture that you're running through there, we can potentially soak up the thermal energy and convert it to static that's being used for the fuel gasification process. And if it's very efficient, then it should actually turn, exhaust that's 1,000 degrees Fahrenheit coming out of the engine. With the bike that I built, it would drop it from 1,000 degrees down to 200 degrees by the time it was done moving through the heat exchanger. And then by the time it would come out the muffler, it would be about ambient air temperature. But
Fahrenheit, of course, right?
What's that? Yeah, Fahrenheit. Yeah. But I think we can potentially make it so that the exhaust becomes even colder than just ambient air temperature if we have multiple reaction chambers that allow us to absorb more of the thermal energy from the exhaust, because it becomes the bottleneck of efficiency is the surface area of the reaction rod. There's only so much time as the hot exhaust is moving past it to absorb that energy. So if we have a manifold that breaks it into multiple different reaction chambers, then we can potentially optimize the amount of surface area and tune the reaction rods to focus on just reforming water vapor. And that should allow us to actually make the water vapor become the primary feedstock for the hydrogen.
Okay, and I gotta talk about the water thing here. That gets me so excited because in the history of free energy, like one of the, I mean, it's a long history, but I guess the recent past we had, what's the gentleman who created the water-powered car?
Stanmeyer.
Stan
Stanley
Meyer.
Meyer, yeah.
Yeah, so Stanley Meyer, created this water-powered car and drove it across the country. So like if we could
But also Walter Jenkins' Thunder clap engine, not to be confused with what Malcolm Bendel thunderstorm generator.
Cool. Another
Right, Wes,
person to look up.
Can you
So
explain
yeah,
that one?
like
Sorry, go ahead. Say that again. Say that one more time.
Walter Jenkins thunderclap. What is that? Like we've been researching thunderstorm generator, and then you mentioned that there's this whole other really similar engine, which also uses like mainly like 95% water, just a little bit of fuel to start a reaction.
Actually, it was brought to my attention by Alex Lozman. It was the Walter Jenkins Thunderclap generator, which was a precursor tech that Malcolm Bendel took influence from. And then there was
Did it
another
use a
series
heat
of
exchanger
patterns.
or use something else like a super spark?
I need to go find the works and the patents and stuff myself, so to see if I can confirm that for sure. But I have a suspicion.
cool.
So anyway.
And to finish that thought, basically, I get excited about this because if you think about the idea that we already have these highly efficient industrial, like we've industrialized it, like atmospheric water generators. So like, and then plus you have the leftover of everyone's HVAC systems is water condensation that we just throw away. So like basically, the idea that if we can build an engine that's running on water, then we could be sucking fuel out of the air.
Yes.
Can I give an advisory for this for legality and safety's sake?
Sure.
One, if you're gonna do this kind of experiment, shut the up. Keep quiet. Two, if you're gonna use this, stick to carbureted vehicles and things that you can get emission waivers, and then give the middle finger to the elites and the eco grifters and the establishment by doing it with those, because you won't. And then you can also get three, if you're gonna do this with the vehicles like carbureted vehicles and whatnot and older vehicles, may I suggest get the Hyco 2A construction plans and build a Hyco 2A vaporizing system for your by George Wiseman on eagleresearch.com, so you can mix a little isopropyl alcohol vapor you can get from Walmart to mix with the output, just to be PC and to keep the glowies off your backside, and so you don't get accused of being popped in the head, popping yourself in the back of the head 4 times, just to be safe.
So that is one reason why I bought this old Mercedes that is a historic vehicle. It has the historic vehicle license on it, so it doesn't require emissions testing. So that is
There
a
you go.
workaround for putting my
Nice.
invention out, where it's prohibited to put it on a vehicle that has like a DEF system on it.
Yeah.
We'll see about getting a waiver or whatever for that.
Yeah. There's another thing too. If you are going to even try to do this on computerized vehicles, there is a circuit system called the EFI, is George Wiseman pronounce it? EFIE, electronic fuel injection enhancer circuit. If you build it directly out of the manual to build it, you can work with narrowband voltage based oxygen sensors from 95, 96 to like the mid 2000s. But beyond that, you need to modernize the circuit and find someone that'll knows how to do this to modernize the circuit so it'll read the modern oxygen sensors in the exhaust that operate on like amps, microamps, watts, and they're wide band oxygen sensors. You need to update that so it'll read those, and you'll have to go to your mechanic friend that'll make the computer shut up and stop reacting. Because what the
Right.
EFI does, every time you use anything that speeds up the combustion or cleans it up or both, you're going to raise the final exhaust content of the of oxygen. So that's gonna, if you raise it up to a certain level, the emission controls will falsely tell the computer, that the oxygen sensors will falsely tell the computer, oh hell no, we're running too lean, we're gonna burn up. So throw more fuel in. So when you're running these combustion enhancement technologies, you'll need a combustion enhancement tech interface enhancer like the EFI.
Right.
To tell the computer, all right, shut up, we're running fine, we're not going to blow up, let's go along, without violating the Clean Air Act laws, which are mandated as law by the feds.
Which is why I'm excited to work with Startup Central, because they do robotics and they know how to program a logic controller to be able to remap an engine, so we can retrofit this device to a computer controlled ignition or a fuel injected engine and remap its computer controlled ignition system.
If you want, I'll link you the EFI manual, both of you. And for anyone that wants to get it.
I want to talk about how we can
plans.
reach over 100% efficiency with the engine, because we know, most combustion engines are only 25 or 30% efficient, meaning that they only effectively convert 25 or 30% of the fuel that you bought into useful energy, and that the engine is primarily a fuel wasting machine. And it's pathetic that it doesn't at least get half of it and make useful at least half of it. Well,
and
we can potentially...
You just stumbled into an area I'm very literate in, but go ahead, you first, Dorian. I want you to have the floor with this first before I jump in.
So,
go ahead.
I mean, we've heard from the thunderstorm generator researchers that we can improve the combustion engine's efficiency from 30% up to like 65% efficiency. But we're just scavenging for thermal energy from the exhaust. But when we start tapping into these water cavitating phenomenon and maximizing that effect, I think that is where it becomes possible to actually not only utilize all the fuel that we're feeding the engine, but also use the water to create a feedback loop of gasifying more hydrogen and actually gaining more energy from a phenomenon. It's whatever it might come from that zeta pinch, or if we're creating a singularity where we're gaining electrons from the quantum foam.
But yeah, you're breaking, maybe breaking the Schwinger limit, and now you're also accessing negative energy from the vacuum or whatnot.
Like the charge clusters coming from the water cavitation phenomenon, and we might be able to
and then achieving over unity would be like you hook up an atmospheric water generator onto the car with a GEET or thunderstorm, and you're able to suck water out of the air faster than it burns it up. I don't know if that's possible, but that would be a cool idea.
We could have a total exhaust gas recirculating mode. If once it senses it's making over 16% oxygen in the exhaust, it just shuts a valve and then starts sending all the exhaust back into the bubbler, and it condenses the water vapor from the exhaust and just reclaims it in a closed loop fashion.
Yeah, and that will extend how much further you go with the same amount of water, because you're not really condensing, but you are recracking it, if you will. But since you mentioned it, there is a specific way you want to. There's a rule of thumb, and I got the math right here. I just pulled up my little notepad here. This is a shortened version of a script I did a while back for a couple videos. First video was busting the biggest mechanic lie of all time. The second video was busting the second biggest mechanic lie, which is about the claim that we use the air-fuel ratios that we falsely assume and program into the computers. First off, 14.7 parts air to 1 part gasoline is only true in the context that gasoline is completely vaporized into gas. and it's open and like external combustion. That is not the environment in an internal combustion engine. Why? Well, you're condensing air, you're sucking it in, the piston comes up to squeeze it, then there's a bang, and then you're letting it out. Let's not get any ideas. I know there's a lot of brain rot innuendo I probably just said there, but John Cadogan ruined John Cadogan ruined my brain with that. But if you want to know how to calculate true air-fuel ratio, first off, you want to calculate how many pounds of air you're pumping per hour. Then you want to multiply how many gallons you burn an hour by, I assume the heaviest weight, make the math easier, 6.3. You divide the pounds per hour of fuel against the pounds of air per hour. That number is how many parts air to every 1 part fuel. Boom. But how do you get, now the air pounds per hour is it's got the most steps, but it's the formula is there. I could actually tell it to you because Alan Wallace theorized the beginnings of it, but his mathematics were dog and really splotchy. George Weissman came along and cleaned it up. I came along and modernized it with more additions from online calculators that you can go get yourself and do this, and more advances to the air, like volumetric efficiency. I'll read this out to you. I'll be quick, I promise. Okay, then in a four-stroke engine, that to calculate real AFR, you must get your choice of engine RPM based on the speed you choose. The intake air temps at either Fahrenheit or Celsius. Get your MAP, in manifold absolute pressure, in either grams per second or pounds per minute. The number of cylinders your engine uses. The pressure of the intake, whether in kilopascals or inches mercury vacuum pressure or suction, and use them on the ATG volumetric efficiency calculator to get your volumetric efficiency. Remember, with a four-stroke engine, which is what all of our trucks, all of our cars use, unless you're talking to the Detroit diesels and military Detroits that they still make parts for, and then they have aftermarket.
Those are two-stroke diesels.
Yeah, that's the exceptions. And they still make parts for those, despite how old they are, because they're reliable. And the IP licensing is almost gone because most of the parts are expired. But sorry. So in a four-stroke engine, only that air is sucked into the cylinders only once every 2 revolutions. So your chosen RPM is only half as many intake suction strokes per minute. Then you must multiply your cubic inches of engine displacement by the volumetric efficiency, multiply that answer by whatever half of the amount of intake strokes you get by dividing, the RPM by 2. Multiply that answer by 60, divide that answer by 12, then that next answer by 12, and then that third, and then that product by 12 for the third and final time to get your cubic feet of air per hour. Then you multiply that number by 0.0807. Why? A cubic foot of air is 807 thousandths of a pound. That is how you get how many pounds of air you get per hour at that speed. If you want more math rigor, go to your local weather system or access to the internet if you want, and get the local air temps, whether in hectopascals or millibars. Convert them into what you need for a volumetric efficiency primer. Convert Fahrenheit to Celsius if you need. Calculate ambient air density using temperature, barometric pressure, hectopascals, kilopascals, or millibar, and then humidity percentage. Convert kilogram per cubic smear to pounds per cubic foot. then continue the rest of the formula I laid out, and that's how you get the pounds per hour that way. And again, I said about fuel, like multiply the fuel, like for gasoline, look at how many gallons you burn an hour, multiply that by 6.3. Always assume the heaviest. It's strong rigor, but it gives you wiggle room of, oh, I could be burning this much more an hour. And that's real physics, pounds-based air-fuel ratio. Now, that's one thing. But most people don't realize this, but one of the biggest reasons we don't get more than 25% efficiency on average is because we're not starting the burning of fuel at the top dead center. We usually have ignition starting before that, when the piston's still coming up. But we do it the right timing enough to overcome that little bit of loss. But that little bit of loss can be removed, and the gains could be magnified with the right type of ignition, whether it's air-assisted,
I've even
air-effervescent
heard
diesel
that
injection.
aftermarket ECMs, or whatever, the computer controlling the piston firing, the aftermarket ones can already get you more efficiency. Is that true?
Yes,
Yeah.
they can, because you can use them to adjust for the top dead center only ignition with higher octane fuels. And so like for diesel, you'd have to do something that can I would consider, I might have to make my own little short video on my channel about how to improve like efficiency with diesel. But then again, I already did some of that on the old hypermiling series, but I need to talk about diesel efficiency more, but in a shorter video, or I'll have to do that. Like you take Orbital Flex DI Tech and its use of compressed air assistance, and combine that with the injection pump and tech of the old school indirect injection diesels. That'll be able to atomize super fine. That could start ignition at top dead center and give you massive boon in efficiency.
You've heard about Mazda's new engine that combines, it's like diesel and gasoline engine in one. It's like high compression, and it used like a long stroke like a diesel engine. And
I know it's a type of HCCI engine. Yeah. Funny you
how does it
mention
work? It
that.
manipulates the valves in a way.
Yep. And it ensures there's a homogeneous charge that only ignites but it manipulates the valves, but there's a certain amount of heat retention in the combustion chamber. So when the piston comes up, it's all the intake air and the homogeneous charge all mixed together, and then it detonates on its own, and then pow. Funny you mention that. The oldest tractor engines in history were the hot bulb engines, which was the first HCCI engine by Herbert Ackroyd Stewart.
So it's using compression ignition, but it's a gasoline engine. It's lighting gasoline, but in the way that a diesel engine does.
Well, it's a homogeneous charge compression ignition, so it's working with high compression like a diesel, but it's using a homogeneous charge to make it self-ignite under enough heat like a hot bulb engine would do. So that's what it's doing.
So homogeneous meaning that there's like the air, it's like already pre-mixed in a way that it ignites more easily.
Yeah. There's enough residual heat and a residual amount of a certain amount of air, and the fuel's shot in there, and it mixes and it vaporizes and makes a homogeneous charge with heat, hot air. Fresh intake air comes in, mixes with that, and then the piston comes up and it pow on its own.
And they managed to get the efficiency. I think that engine's over 40% efficient. Is it like
now
45 or 40?
Since you mentioned it, folks that are watching, you're going to be in for a treat, because the biggest thing. So this plays into what I've been saying this beautifully. So thank you, Dorian. So what happens? You want the ignition to be top dead center, and you want the combustion, like in a gasoline engine, you want it to finish anywhere between 18 degrees and 20 degrees after top dead center. You want everything to be burned up, completely used up by that point. Because
rotation of the crankshaft.
Well, the piston will start coming flying down and if you still got combustion still going, it's going to get diluted by thinning out if it's still going after 20 degrees. And that's where a lot of your excess heating is come from, your NOx emissions, your hydrocarbons, all that is formed because combustion's it's not burned up and done with by that timing. It continues to do so. That's also what enables carbon and coking on the exhaust valve and all that bullshit.
It's like the combustion is continuing in the exhaust pipe, basically.
Partially in the exhaust valve, partially. Yeah, it's because of that. So you want, in a gasoline engine, you want it to finish at the latest, at the crappiest, 20 to 21 degrees after top dead center. But when it comes to a diesel engine or a HCCI type engine, like we just had a back and forth on, you want that because it's a somewhat slower burning cycle. You want that to end and be done with by anywhere between 24 to 26 degrees ATDC after top dead center. For the same reasons after that. And you're still going to maintain a little bit of residual heat, more than enough to restart the process in HCCI, and more than enough to ensure that vaporization happens when the diesel fuel or whatever alternative you're going to use out the diesel injector nozzle shot out, because the compression, they're both acting like fire pistons in a way. In certain ways, they back like old fire piston fire starters.
Conventional combustion that we're talking about. But when we start adding ionized gases to the combustion process, then it becomes something else.
Well, first, you're right. If it's excited enough, you're right. But it also plays in exactly what I'm saying by speeding the combustion up when it detonates, when it self-ignites, when you got the deuterons and tritium ions, a few that might be there, in the GEAT or thunderstorm generator, like plasma syngas collapses on itself and condenses down, pulling intake air to it, and hits that little density point, then the Leonard can happen there too. So you got 2 points of potential Leonard. In the zeta pinch, in those either the round the rod or in the Vajra points of the TSG, and at the combustion chamber itself. That's 2 points of potential Leonard action. And the Leonard action of the combustion chamber is what makes the self-ignition happen. Because of the excess heat energy, because it's literal freaking fusion. Deuterons, baby, deuterons. Heavy water out in nature.
Does the what is this, HDCCI?
HCCI, homogeneous charge compression ignition.
Does it have spark plugs?
Some designs were experimented with spark plugs to kind of start them, but they're not supposed to with the best operation.
Got it.
For example.
I'm seeing that it says does not use spark plugs, highly mixed. So I guess the point would be it's a gas engine that doesn't need spark plugs.
Yeah, and it also parallels the diesel, but it mostly parallels the hot bulb engine, but way more efficient.
So replacing spark plugs with ionized gas.
Well, in the case of using a GEAT or a Vajra, yes, but in the case of a HCCI, you're retaining a certain amount of heat in the combustion chamber or a pre-chamber swirl area, and a certain amount of air, and then you're pre-vaporizing fuel you emit through there, and then it retains enough heat that the compression heats it up, that mixture enough that it just detonates on its own.
It's almost like a return to carbureted engine.
Almost, but not quite. Because
the fuel pre-mix.
To an extent, but carburetors, they have a couple of design issues that are easy to fix, but no one wants to do it. Tony DeFeo, he's affectionately called Uncle Tony for the YouTube channel Uncle Tony's Garage, actually has talked about this in Fuel Economy and Classic Cars video series. He even had talked about he is the only legit mechanic that I know of actually vindicated Smokey Yunick's hot vapor concept.
Oh yeah, talk about
And he
Smokey
even,
Unit.
yeah, I actually was going to do a video not too far off from now about the, I'm intending to, on
Homogenizing carburetor.
the Smokey hot vapor engine. And I'm going to debunk some myths, but I'm going to teach people how you can reconstruct this and do it yourself if you wanted to.
You had the Pontiac Ferio.
Yep. But it can be used across all sorts of engine designs, my boys. It can be
Yeah,
used
he
across
put it
all
on a
sorts.
Pontiac Ferio just as a demonstration car.
Yep. Actually, I think it was I think it was more than just one. I think there was a couple, I think. One, I
What were the
forgot
stats
who's
on that car? It made like 240 horsepower and it got 40 miles per gallon.
what, but another one was tweaked just right and it got 50 to 52 miles per gallon and a little bit more, just a little more horsepower than that.
So yeah, it's like peppy like a sports car, but it can smack down a Prius in terms of fuel economy.
Absolutely. Well, and what's really screwed up, this same tech can be applied in an ultra lean manner into the intake of a diesel engine to
Huh.
imitate what the Heiko 2DT does by George, which is the thing George. This is another Heiko version developed by George Wiseman. It works with turbo diesels. This same effect can be used to inject in small amounts to make a homogeneous, ultra lean homogeneous charge. It's lean enough that it won't auto ignite because it's too lean, but it's still there enough to turn the whole combustion chamber into a ignition point and speeds up the diesel or biodiesel or whatever combustion. It'll work the same way that way. Just more effective and more ensured of a homogeneous charge is being injected, but you just have to really lean out the amount you're shooting in the intake. But it can work the same way. The Smokey Unit.
As far as I know how his invention worked, it was also a heat exchanger that would preheat the fuel first using the heat from the radiator and the coolant system.
Yes.
And then it would heat it a second stage using a heat exchange with the manifold, the exhaust manifold, and break the fuel down basically into hydrogen gas, like kind of like a thermal pyrolysis reforming, basically, right?
If you use the right catalyst metals in the construction of that particular heat exchanging, yes, it can. But if you
It's basically
don't,
like putting the catalytic converter before the combustion or before the engine rather than after, treating the exhaust with the catalytic converter in the exhaust, or like pre-treating it, breaking it down into something that's very lean burning.
If you use the right catalyst metals, and I already theorized a couple of candidates for that using manganese bronze as a base with a couple of catalyst alloying additions, certain percentages, to not sacrifice strength but still be enough to be a catalyst for this type of process. It'll look very unique, though. I'll give you that, because it's literal type manganese bronze. But if you're not using that right catalytic metal in that heat exchange, what it'll do is it'll just be a very efficient, hot, homogeneous vapor feeder. And it will still work. But the catalyst
So what do you think the
factor,
fuel to air ratio was in the case of Smokey Unit's engine?
holy Christ, I'd have to do the test. I'd have to
You
do
think it was more like 50 to 1 instead of 14 to 1?
Oh, absolutely. Probably even higher, potentially. Holy Christ. Oh,
Really?
wait, definitely higher. I'd have to see how many pounds of fuel is getting sucked into the carburetor that starts the process, and how many pounds of air and how many pounds of fuel is burning an hour. And I would have to give that ways to do that in the video I was going to do, breaking down the myth busting, because I'm gonna tell you guys something. Those temperature readings on the patent are a smoke screen. They're a BSing screen. There was a forum talking about this very thing, and Smokey Unit mentioned to somebody there was a fuel additive for gasoline that made it possible, and the fuel additive was BS, which was the funniest I read in a while at that time. Which told me, oh, he's booting us. It's a smokescreen. You don't have to have temperatures that high like in the patent claim. You could still make this work. And that's when I had to do that together, which was
So basically, we can get
hilarious.
more efficiency with Smoky Unix design. He basically was showing that we could get better fuel economy by breaking the fuel down. Instead of gasoline is like a hydrocarbon that's like 20 hydrogen and carbon molecules long, we're basically breaking down the chain using thermal pyrolysis and getting these free floating individual molecules of hydrogen that burn so much leaner and more efficiently. And the hydrogen has a faster flame front. That way it can burn all that leaner little bit of fuel it gives it. It can use it all in the little bit of duration of the time during the power stroke. That way there's no unburnt hydrocarbons going out the exhaust.
Right. And it would burn within that proper time limit, that the engine timing limit, like I mentioned before. Yes. Only if you use the right catalyst alloying that can ensure the thermal catalytic cracking happens at the exhaust heat exchange area. But if you're not, it still makes a hot homogeneous vapor that can mix with cold intake air and make a warm vapor that'll still get really hot and still burn very efficiently and completely and still burn efficiently, and it would still be a hot vapor engine at the worst, and you would still get a crapper ton more mileage and lower emissions. But you're right, but you have to have the right catalytic alloying for the tubing at the exhaust to vapor mix heat exchanging area. But you also got to worry about another thing now. If you do this, you got to make sure that the turbo works well enough as a one-way valve to stop back pressure from building up for doing this kind of reaction. Because let me tell you something. Say you thermally crack a molecule of decane, and you make 8 to 10 molecules of methane, like natural gas. That's going to generate a lot of volume expansion. That'll make a lot of back pressure. You're going to need something that's going to keep sucking and pulling as a one-way flow valve to fight that. So you want a really good turbo. Fortunately, I already did videos on the Tesla turbine, the Tesla turbine advances, and the Tesla supercharger and turbocharger concepts, and how to ensure that it's possible to be done. It'll be the most efficient turbocharger in history from here on out. And it would absolutely slaughter at doing this. And you can drive it by the conventional turbo, centrifugal wind turbine for the exhaust that we already use, and it would drive it. And that would absolutely ensure that. Now,
I do want to combine a turbocharger with the hexameter. It should be compatible with a turbo diesel engine.
Yeah, it should. In fact, the turbocharger will ensure that the oxyhydro plasma syngas coming out of the TSG will be fully homogenized with enough intake air, so it'll make a decent homogeneous mixture. But the trick is to keep it lean enough so it won't auto ignite on its own, but let the diesel ignite and be burned up super quick. And that's the kicker. Because the diesel burning up at the cycle the combustion ending at 24 to 26 degrees after top dead center, that's when you really get the efficiency gains out of a diesel or an HCCI.
I wonder if the diesel engine could potentially extract more power from the implosion effect too. Being compression, like having more compression. It seems like the implosion should initiate the implosion sooner and potentially get more stroke, more compression stroke, more power.
Yes, but there's even more that could be done. If you make
because we can potentially turn the compression stroke into a power stroke once that implosion starts happening. And if we have a longer stroke, then we can potentially extract more energy out of that implosion, I believe.
Not only that, but remember the little details I gave you a while back about putting a vacuum or a pump that pull a vacuum consistently through the intake, how it can give you at bare minimum 30% more performance and more efficiency on the reactor. This would work with the TSG or the gate. And remember what I also showed you, how you can make an exhaust clenching and narrowing down, like an exhaust pipe venturi around the intake pipe. It can also give you a 30 to 40% gain. And you put the two
And
together,
more horsepower,
woo,
right?
baby.
So that's because that constriction in the flow of the exhaust gases around the heat exchanger, that's somehow creating some kind of suction in the exhaust. It's helping like pull the
Yes.
exhaust, like it's turning the exhaust stroke into like it's like vacuuming the exhaust out and actually creating that's driving the piston of the engine as well.
Yes, and the extraction of the heat and kinetic energies is amplifying the Venturi and Bernoulli effects on the exhaust pipe you're using to as the heat source for the reactor in question. Yes, it's doing all these
So
things.
we're basically
it's
that's
gonna,
a way we can potentially turn the 4-stroke engine into an all power stroke engine. It's power stroke on every stroke.
except for the intake, but yes.
Yeah,
So the
and well,
latter
if
three
we
strokes
have
could
a
be.
the momentum of the turbo can act as like helping pressurize that stroke, and that can also make it so it's like gaining power from that.
Yes, if you use. Yes, but the trick is you're going to have to rely on the every other exhaust pipe outlet that's not being used by your hexameter or the Challenger reactor or a gate reactor or a TSG, because there's not going to be enough. There's going to be more pressure and kinetic energy than the ambient environment, but it's not going to be enough to really strongly spin that exhaust turbine. The others will have to be relied on to do that. So it will pressurize the intake and enhance its effect only if you use the other regular exhaust pipe for doing this.
Hmm.
Because the exhaust
Yeah.
coming off of either of these reactor choices it's going to be much weaker, and it's going to have less kinetic and heat energies because it's going to get so thoroughly extracted. I mean, it'll be enough to puff and you'll feel it in your hand, but it's not going to be quite enough to help drive the turbo.
Yeah, Clay Richardson at Startup Central, who I'm talking about collaborating with on this, is also talking about how we should use an electric pump in order to maintain the vacuum pressure coming off the top of the hexameter reactor. Um, the turbo could help maintain that pressure, the momentum of the flywheel effect of the turbo, but we
Yeah.
could also compensate or manipulate it with an electric pump as well.
You can also use a smog pump, which most engines have. You can use a vacuum-driven rotary vane pump, like fuel pumps on small equipment, like lawnmowers that use the vacuum of the valve system. There's all sorts of ways to do them the same.
Yeah.
So, it's all sorts of ways of doing that.
Yeah, I cannot wait to see the fabrication of my hexameter device that should be coming here in the next month, I believe. Waiting for Startup Central to move their machine shop right now. But I'm in talks with them about the method of how we're going to fabricate the device. And I'm also starting to work on making a motor mount for a new bike that will act as a platform for testing the hexameter reactor. We want to build a generator, an electric power generator, and a moped as the first initial uh, test platforms or products that we're going to put to market.
Awesome. So excited for you, Dorian. And we'll put all the links to, you've got a GoFundMe. I pushed you to start a Patreon, so you got a Patreon now. Wes has a Substack, so I'll be putting all those links below so you guys can support these backyard mad scientist inventors, building this cool, like, this is like the real green technology, right? This isn't greenwash. This is actually like, this could actually save the planet if the majority of our gas, coal, and industries switched over to some of these things. And like you're explaining, there's
Yes.
all of these untapped effects that we can integrate into our modern combustion engines to just get more efficiency out of them. So like, but being able to design it from the ground up, in a shop, integrating all these effects together and seeing how they synergize, then we can, hopefully maybe hit such a high efficiency that, and especially being able to swap the gas or diesel, for more raw, like you were saying, raw crude, and then eventually swapping in some water. You're already putting in some water with thunderstorm generator through the bubbler, and then eventually switching it over to 100% water. And that's what gets me really excited. Yeah.
Hey,
That
can
is the
I
goal.
also go ahead? Yeah, that's a goal. Can I also give you another implication for the public that might be interested in hearing this out? This is a really wild one, but it's let me go to a DM on Discord with a certain individual that I talked about this with. Okay, apparently, give me a second.
All right.
Anyway, I found it. Let's say we got nuclear reactor tech and it became mainstream, the clean nuclear tech. Like we got, say there's a great implication for the gate, for example, with the right optimum gates, the gate reactor systems. Breed plutonium out of uranium-238, enrich uranium-235, concentrate it as much as possible. Have reactors that breed the plutonium and generate power. We take the plutonium, the wastes from those reactors that have already used it and stuff that has been buried. The enriched and concentrated uranium-235 that can be mixed 90 to 91% thorium into pellets for these CANDU reactors to be fully burned up. The last waste would only last for 200 to 300 years, but here's the thing. Why bury that bull all over again when you could just take it, rip it down into nanoparticles to suspend in water to make a colloid solution, and transmute it away? I'll give you an implication. Think about I think it's like 200. Let me think. Give me a second. I'm trying to remember. I think one of the isotopes, I think it was like, what was it, polonium, a polonium atom, maybe? I'm trying to remember. You could rip that down potentially into a decent number of oxygen molecules in an output of a gate, or 207 point something ions of protons or ions of hydrogen, for example, for polonium.
This process can be made possible if we have an engine that can do a total exhaust gas recirculating, meaning that the low energy nuclear reactions taking place in the combustion process are putting out enough oxygen in the exhaust that we can recirculate that exhaust back into the intake. Then we can actually use like old radioactive spent nuclear fuel and transmute that radioactive toxic crap into oxygen with this process, basically making the engine use that as a reclaim.
Yes, but here's what's really screwed up. You don't even have to do the closed loop thing to do this. But although if the conditions are right, you got to make sure that the plasma and the Z pinch and all these conditions, the electromagnetic, kinetic, electrostatic acceleration, the discharging, the electromagnetic fields, let Faraday and Lenz's law happen on the bullet rod and the two pipes. All these things converge together and nestle each other enough to ensure this. Then you'll have these transmutation possibilities happen, and then the closed looping of the
that'll help
of the
ensure
exhaust,
to make sure it all gets transmuted, so you're not polluting the environment by putting radioactive exhaust out.
Well, it's not if the conditions are right, it won't happen at all. It won't be putting out. You'll just extend the runtime with the closed loop. If the conditions are right, you won't have to worry about it at all. That's the whole beauty. Like Paul Pantone took a demo engine. I forgot the name of the guy he was hanging with in Japan, but this guy figured out how to mess with Brown's gas and figure out how to make like a ball lightning of sorts, like a ball lightning effect, and keep it going with Brown's gas. And you could vaporize stuff. He had vaporized atomic waste through it, and Paul Pantone cranked the geat up to suck the vapors of that in and then transmute it away, and it didn't have a closed lip. There was nothing coming out the exhaust. So then I forgot what university did this at. These two guys, Paul Pantone, the other guy. I'm trying to remember the name of this other guy. I did this, and the Japanese professor said, "Hey, we love what you're doing, we really do, but we want to stay alive, and we want you to stay alive, and your colleague there. So you might as well stop doing this to get the hell, HE double hockey sticks out of the university, not do this again." And then Paul asked why. He said, because politicians get paid billions of dollars to bury the nuclear waste instead of reuse it.
So, and that's a great story. Thank you for sharing that. So in essence, the geat and the thunderstorm generators can also be used to clean up, industrial nuclear waste en masse, and not just clean it up, but now you're powering your car, and the byproduct of cleaning up the nuclear industrial waste is, powering your car and your lawnmower and your off-grid generator and all your chainsaw.
Oh, I got it. I found it. It was the wrong DM I was looking at. I remember now. I got it. Let's say you wanted to transmute down polonium-209, which could be made by irradiating bismuth with alpha particles from plutonium, thorium, uranium-235, whatever. That's for the analogy here. You could generate 207 protons, 6 molecules, and certain number of atoms of oxygen gas, or any combo thereof, from transmuting down an atom of polonium. Now think of how huge that implication is on single atoms of atomic waste that are higher in molecular and atomic structure. Suspending them in the nanoparticles in a colloid with water.
So I'm just curious.
You take a little bit of that colloid, that makes a ton of oxyhydroplasma.
I'm curious, would it be? Are the people like handling this radioactive waste? Like, are they in, hazmat suits and like lead shielding? Like, how, conceivably, would it be realistic for people to actually use it as a gas? I guess you could conceivably create engines and develop.
Probably at only industrial or like recycling facilities, like power plants that are built to actually reclaim.
Yeah, that could actually be done. Yeah.
Yeah, like he said. Now, if we had this idea where we had dual fluid nuclear reactors and CANDU reactors that use primary atomic wastes from fissioning like combos of like uranium, like 238, or to breed plutonium as part of the process, like the breeder reactors, you know what I'm talking about, that breed stuff but also generate power. If we use one of those to breed plutonium out of 238, then we enrich concentrated uranium-235, and then mix that with the atomic waste in pellets or just with thorium and burn the mixture in a CANDU reactor for a complete burn up. Or we added dripped these into the dual fluid reactors in a way that prevents the fission poisoning byproducts of fissioning thorium from being enabling to get transmuted away. The final reactor waste from these processes would only last 200 to 300 years, but the radioactivity is still weak. I mean, you could probably block most of it with this rag because it's so weak.
Okay, that's what I was wondering about.
But potentially, and now you could still maintain the same type of protection shielding just for the heck of it, maybe. But
yeah. Well, but for sure, if you're already producing the waste right there at the plant, you may as well create a gigantic industrialized, sized geat reactor or thunderstorm generator to generate even more electricity and just clean it right there up at the spot. On the spot.
Or better yet, or even better, you could get a few 20-horse Briggs and Strattons to act as servant engines, feed them a small percent of the output of a big gate reactor or TSG to keep them going, and then feed the rest to big industrial generators to act as additional source of power.
So
So
yes,
you
this
got multiple
technology is the
stages.
solution to making us independent from foreign oil and fossil fuel in general, and it can clean up nuclear waste and make us no longer really need conventional nuclear reactors. It's basically the solution to all the military-industrial complexes bullshit, and it's no measure of health to be well-adjusted to a profoundly sick society. So we will press on in the development of this technology.
Yeah, and it also just, I mean, you know, I guess it's just the message to the, the military industrial and like the gas, coal, and oil sectors. Like, it actually makes you more money to embrace these technologies. Like, there is money to be made. Not that, like, that is kind of the problem in the first place, but it is a win-win situation. So it's not like,
Can be.
suppressing it actually just makes them poor. It makes all of us poor right now,
Well,
especially
yeah,
with what's going on in the Middle East. We're all getting squeezed.
but the thing is, it's politicians and IP and all these political barriers by the collectivist right and the left and all the establishments that are being the blockades of this. Because this is real profitable market environmentalism type solutions that can really shoot us forward. People could do in a private
could be,
setting or a communal setting, like some of my Market Socialist friends would like to could do this and bank
we
on
can
it together.
have a whole new zeitgeist for humanity and our meaning of why we're on this planet, and no longer have to feel like a cancer that's polluting the planet with carbon or whatever, carbon footprint, blah, blah, blah. It's time for a
Right.
new meaning to our experience here on this planet.
Don't get me started on how that message is a psyop. Don't get me started.
Yeah, I will say there's a silver lining of what's going on in the Middle East and how gas coal and, or gas prices are going up, gas and oil prices, and also derivatives of oil and petroleum products are going up. So the silver lining is, so I follow Mike Adams, the health ranger, and he just interviewed someone who's works in cold fusion, or LENR. LENR standing for, so it's LENR, low energy nuclear reactions. So he interviewed him some years ago, but they didn't really have the funding. But it was a guy, they're basically associate, and you can go to the Health Ranger Report on YouTube or Brighteon.com and find this video. I'm not going to look at it, but I can't remember the name of the guy, but you can find it if you look it up. And I'll put it in the link below. But basically, they got funding all of a sudden, literally just like in the past couple of months, because of this Iran conflict, because the prices of oil and gas are going so high. All of a sudden, there are now billionaires that are interested in cold fusion and all of these alternative energy technologies. They're all of a sudden interested, and they just got the funding, so they're literally now building their. I think they mentioned they are going to be building residential units. And I should really, I got to find the video and stuff to describe it more. What exactly this particular device was. But just that is a huge signal that basically,
the time is ripe because we're in an
Yeah.
AI arms race.
yeah,
New
and the
energy
data
technologies
centers.
are going to be demanded. Is this time, in spite of invention secrecy laws or whatever, it's time.
They're building data centers that already in the middle of the construction, they're having to stop it and cancel it because there's not enough energy. So like,
stupid.
you have to have.
It's idiocracy live. Stupid.
But not
they're
only
now.
that, but
Yeah.
not only that, but like easily half or more of these data centers are also surveillance centers to watch everything we do, like a bunch of perverts.
Yeah, I think they're running simulations where they, in the past, they would run wartime simulations of trying to predict what will happen as a result of a naval skirmish or whatever. And now they're applying those abilities to make predictions about outcomes to everything they can data mine. And so that is a danger. I mean, potentially this computing power could be used for the benefit of humanity. Like we could have, blockchain based voting systems that, are unhackable, and we could have, democracy 2.0. Yeah, we we should be wary of the technocrats and what they are planning to do with data centers. Is it just to compete with the Chinese and stay ahead of their total tactical compute power? Because that's ultimately what it is. It's about how much tactical compute power we have as a country, I think.
You know what's even wilder? What's even wilder is we have not invented probabilistic computation yet. Now, when probabilistic computation gets invented, the bare beginnings of it, and it gets integrated with quantum computing, some crazy starts to kick off. I'm calling that because I know the bare minimum, surface scratching, and I have friends who actually understand computation and can explain it to me like I'm a Downy. So let's just say some serious is going to kick off. When probabilistic computation gets invented and it gets paired with quantum computing, that's going to be the wild one. Actually, hell, not even just probabilistic computation alone is going to be an explosion. Info explosion.
And can you describe? So, what is probabilistic computation?
Probabilistic computation is also it's a computing and programming paradigm based on the declarative specification of probabilistic models, which for inference is performed automatically. It's also a type of programming language.
There's if this is the same as there's these other, and I'd have to think of the name, but there's someone I'm following that created this new quantum chip that sounds very similar. Superstition. I forget the name of this guy. But yeah.
It might. There are some overlaps between advancing of computation as a whole and these quantum computing chips, but it's not the same thing because all quantum computation, all quantum computers still operate on the mainstream deterministic computing model. So technically no, but there are parallels. It's just it hasn't been made yet, and I got a couple links if anyone wants to read them.
I want to reiterate the idea that all this industrial power demand from things like data centers should potentially make the average household should be made rich by having their own microfusion reactor, like a hexameter or a thunderstorm generator at home, and having it IEEE certified so it can send power back onto the grid, like solar power is net metered back onto the grid. Every household should be able to get rich and pay their mortgage with money that's owed to them from the electric company by sending this extra energy on the grid.
Yeah.
Okay. Based on that.
By the way, here's a simplified definition. Probabilistic computing is a computing paradigm that basically embraces randomness and the law and probabilities in the law of probabilism, as well as uncertainty, rather than trying to buck against them or eliminate them like all of computing still does at this point. So probabilistic computing is going to have some wild. It'll solve really complex combinatorial processes. It can actually make generative models across the board. It can blow current computing out the water completely. And then when paired with actual quantum computing gets paired with this, by the way, the bits are called p bits or probabilism bits or probabilistic bits. By the way,
I found it. Extropic. There is a company that's already built this, and I've been following them for years.
Oh, well, that's good news, but it's. I bet it's
thermodynamic. So Extropic is widely considered a front runner in the space. Founded by former Google quantum AI scientists, the company is building thermodynamic sampling units, or TSUs. Instead of fighting thermal fluctuations of microchips, Extropic's hardware treats the thermal noise as a feature, using it to run probabilistic machine learning models and heavy statistical sampling algorithms, and I am just going to check if it's actually available to purchase yet. I'm pretty sure they're still in the R&D phase, but I've been following these guys.
Well, there's a thing though. Probabilistic computers use specialized hardware, and I'm not sure if this is using the specialized hardware in
Yes,
question.
they built an actual specialized chip. Okay, so here I'll drop the link in Discord so you can look at
because you'll want it because magnetic tunnel junctions, organic polymers, and such too. Okay, this might actually be doing it because if it's harvesting environmental noise instead of trying to filter it as part of the computation process. Well, you did read that off. It did.
Yeah, these are the guys. It's exactly when you mentioned that. I was like, I know I've been following these guys for a while.
Yeah. Okay. Thank you for showing it. This is a direct precursor to full blown. This is a direct precursor to the full blown thing. Thank you.
Yeah.
Awesome. This is great to know. Thank you.
Yeah, so and I'll put it in the link below, but let's see if I can find about and just read off where they're at. Read the paper, open GitHub. Okay, so that's cool. They're already putting stuff on GitHub, so they're going open source. Found in 2022. But yeah, anyways,
awesome.
it is getting done. And so I mean, we're getting to the weeds here. Also, we're 1 hour and 40 minutes in, so we can start thinking about wrapping up the podcast. It's late here, I'm getting sleepy. But yeah, this is really great.
Yeah.
We've I like the trading of ideas, and it's fun to let the audience in to hear how to, mad scientists start we're basically sharing with you guys like the conversations that we have behind the scenes. So you're getting to hear this is the things that we actually talk about. And, because both of y'all have already built Geet reactors. Dorian, you built that Geet reactor bike, and Wes, you've built a couple too.
And you're about to begin your own build, Ash. And
yeah,
we're here to
I've got everything.
Nurture that building.
I got 3 Geets. One, it's finished. I'm just dealing with IRL stuff right now. I'm trying to wait the weather out so I can finish because the weather's getting in my way of multiple things. Then so I could get my tiller running, and I'll install my first reactor on my tiller. The next 2 reactors, I'm gonna finish them, and when I manage to get down payments and buy the equipment I want to install them on, I will then get that. I'll do that. I'll get that sucker, or I might just save the capital up because to hell with the biometric, authoritarian, peeping Tom types. I might just accumulate the capital and then just buy it all up all at once. Get myself a generator that's big enough to power the house, and put a gate to that. For political reasons, I'm not going to specify what fluids I am going to vaporize and transmute in it to keep the glowies off of me, but I'm going to do something to be and run my freezers and all that stuff on it, and my refrigerators on that instead, and then let the rest be tapped onto the grid. So again, more way they'll just leave me the hell alone.
Love it. Yeah, and I've also got my I have a thunderstorm generator kit, which, by the way, you can order from. I'll put the link below, the website you can order it from, so you can modify your own. Yeah, thunderstorm.tech. There's one other website. But yeah, and I bought it is a, let me look it up here, but it's an off-grid generator. It's like 300cc. It's the common brand. It's like that name brand. It's generator. I'll tell you, my brain is not working right now. Yeah, it's the Westinghouse.
Awesome. See, I was telling Dorian, and those of you still watching, I was telling Dorian and Ash that my go-tos are gonna either be Duramax or Westinghouse, when it comes to combustions, anything that's like Briggs and Stratton or Westinghouse built, I'll go that way when it comes to the engines, because I know they're reliable. Because Briggs are hard to beat. I'm not gonna lie, they're hard to beat.
So hopefully next talk that we record, Ash will have some progress on his build, maybe have his engine running, and we can discuss more, compare notes on what we're finding in terms of fuel economy and emissions tests, and corroborate the science.
Yeah.
Absolutely.
Follow the science.
And what?
Oh, you
If
go
you
ahead.
follow the science, it leads to my bank account.
I got several jokes. I don't know if I should say them here on this podcast for certain reasons. I got
We're
at
gonna take
least
it to Rumble for
5.
these Tony Fauci jokes.
Yeah, we're
No,
gonna
this
have to
was-
start a Rumble.
Talk about Bill Gates
Uh,
being on trial in the Netherlands, Albert Bourla and Pfizer being taken to court for their safe and effective bullshit.
Yeah.
Well, the one I'm
Okay,
only
family.
gonna hint at. I'm only gonna hint at some of them.
Keep that tinfoil strapped on tight. We're going deep down these rabbit holes. One
Tank
love,
deep
family.
would be an understatement.
Yeah.
Let's talk again soon.
Yeah.
Yes.
Cool. I think it's a good stopping point. Peace and
I was
love,
gonna-
y'all. Thanks,
I
Wes.
was gonna mention.
Go ahead.
Yeah.
Go ahead.
Before I theorized the sci-fi genre concept. It's similar to steampunk and diesel punk. I called it carburetor punk. I theorized it back in 2023, 2024 around May. It's emphasizing retrofuturism of synthesis of like modern tech computing, but it appeals to from the 40s to the 80s aesthetics, and emphasizes carburation and stuff. So it's a new retrofuturism for sci-fi concept. Carburetor punk.
Nice. I love it. Yeah, it goes right along with Fusion Punk.
Yeah.
And honestly, this is I might have to either start a second podcast or just when we start our recordings, we'll just call it whatever, because I didn't go into it, but I wanted to talk about the Tom Bear. I also just want to talk about like other over Unity free energy stuff, like the Floyd Suite device, and I was learning more about that from listening to Tom Bearden's old talks again. It's okay, I'll just give a teaser because I'm self-oscillating permanent magnets. That is the simplest free energy generator, because we're talking about like, modifying modern engines. It's like they are super complicated, man. Yeah, a self-oscillating permanent magnet, like that is the simplest free energy device like ever. But yeah.
You at the Tesla Tech conference.
What was that?
Come meet me at the Tesla Tech conference in
Yeah.
Albuquerque, New Mexico. No,
If I don't go this year, I am definitely eventually going to come. I mean, by the time I build my generator, I will be going to the next conference, and like we can all meet there.
If I don't make it if I don't have the IRL stuff fully sorted out to do the Tesla Tech conference, I am going to make a virtual presentation for people to come on live to interact and do the Q&A. But I'm getting help making the slides for me, well, partially. I got the info, but I got a friend who's more artistic and can do these things, because I don't know what the hell I'm doing with this stuff. So I got a friend helping me with that, making the slides, helping me with that. Yeah. So I got to back up if I can't make it to the Tesla Tech. So I'm still going to do it, and I'm going to have people interact and do a question and ask, and it's going to be about the Moray radiant energy system and my 16 years of theory building and research off of already established physics.
Oh,
and yeah.
Awesome.
That's already on my Substack, by the way.
Yes, please y'all subscribe to Wes's Substack. In fact, let me pull up it is derpyredneck.substack.com. So that's DERPY redneck.substack.com. And Dorian's new Patreon is patreon.com/CW Dorian the Disruptor. That's Dorian, the Disruptor. So yeah, please support these guys if you want to see these technologies come to life. These are the literal citizen scientists and engineers, like taking their own money and what little free time they have, and they're like building these things. So, yeah, I'm super inspired by it. I'm trying to emulate y'all and start building stuff myself too. So yeah, hopefully we have some
Certainly
more
appreciate
updates.
your Ash.
Yeah,
Yeah.
thanks, Ash.
I
Seriously.
I love you guys too.
Thanks for hosting this.
And yeah,
Talk soon.
there's gonna be more to come. So peace and love, y'all. Have a good rest of your day or night, and we'll see you on the next episode.
One love.
This has been West Shrimp Po' Boy Savage coming at you once again.
Ash Growem out.